Hello everyone, in this video I am going to teach you how to delete a node from a linked list. First I will teach you how to delete a node from the beginning of a linked list. See, now this is the linked list given. Now you should delete the beginning of a linked list. That means this first node you want to delete. See, first we should check whether the linked list is empty or not, because if the linked list is empty you can't delete any node from it. So see how to check whether the linked list is empty. See, head is a pointer which points towards the first node. But if there is no node means head cannot point to any node, so head will be 0. So I am writing the code. See here, I am checking whether the linked list is empty by if head equals to 0, then print empty. If the linked list is empty, I am printing it's empty, so I can't delete any element. Now see, this is else part. Now I am checking this condition whether head is 0. No, head is 100. That means there is node present in the linked list. The linked list is not empty. Now see, now you want to delete the first node. First node means the node 100. This I want to delete. How to delete? See, first, now suppose you are deleting first node. If you delete this node means now first node will be this node. 200 will be the first node. So head is a pointer which points towards the first node. So if you delete this node, head will point to 200. So that change I am making. See here. Now head will be 200. Now where can you get this 200 from? 200 is stored in this pointer. So I'll get this pointer value and head is now pointing to next node. Now this is considered as first node. Now this node is not part of a linked list. Now linked list is having only 3 nodes, 200, 300, 400. Now see, now you should remove this node from the memory. Even though it's not a part of this linked list, but you should remove this node from memory. Why? Because data is stored in it. Now this is garbage value, you don't need this data, so it causes memory wastage, right? So that's why you should remove. So how to remove? For accessing this node I need a pointer, but head was pointing at starting here, but now head is moved to here. So how to access? So I'm creating another variable called another pointer called temp. Now this temp pointer should point towards first node. That means 100 should be stored in temp. Now where can I get this 100 from? You can get it only from head, but head is at starting head was pointing at 100, but now head is moved to 200. So before moving head to next node, you should store the head value here in the temp. So see here, now I am writing how to do. Head is pointing in the first node, that means head is having address 100. Now at starting I am creating a pointer called temp, and temp is equals to head. Now see, head is 100, so I am putting 100 in this temp. So temp is pointing to the first node. Now you should move the head pointer to next node. So see here, head equals to head next. Now head is what? Head is 100. 100 next is 200. That 200 is put on head pointer. So this is 200 now. So this head pointer is pointing to the second node. Now see, now this is a garbage node. This is not part of a linked list. So you should remove this from memory. So how to remove? There is a pointer called temp which is pointing to this node. So I am writing free temp. Now see, temp is 100. So this node 100 is deleted and its link is also deleted. This is how you should delete a node from the beginning of a linked list. Now see, now I'll teach you how to delete a node from the end of a linked list. That means last node how to delete I'll teach. First I'll teach the case when the linked list has only one node present in it. See, this is, I'm taking a head pointer. Now suppose in a linked list we have only one node. Let's say the address of this node is 100 and data stored is 8. Now in this pointer 0 will be there because there is no node after this. So now see, now head is a pointer which points towards the first node. This is the first node as well as the last node. So 100 is the address. So 100 is stored here. And this head pointer is pointing towards this node. Now see, now you want to delete this node. How to delete? See, now if you delete this node means there is no node present in the linked list. So head pointer will be updated to 0 because head can't point to any node. So this pointer will get cancelled. Now this node is not part of a linked list. Now linked list is empty. Now see, next step after updating this head value to 0, the next step is you should remove this node from the memory, because data is stored in this 8 is stored, that means the data is stored in memory. Now this is a garbage value, so you want to delete it or else it will cause memory wastage. How to remove this node? For this I need to access this node 100. Now this head is updated to from 100 it is updated to 0. So how can I access? So I am creating another pointer called temp, and this pointer should store the address of this node 100. Now 100 was stored in head pointer, but head is updated to 0. So how can I store 100 here? Before updating this head pointer, you should store the head pointer value in this temp. So it stores before 100. Then this pointer will point towards this node. Then afterwards you should update this head pointer to 0. Then you can this link will get cancelled, and now you can remove this node from by using free temp. Now see, let's see how to do by writing the code. Now this head pointer is not updated. See, this link is there. Now at starting, I'm creating a pointer called temp. See, I'm writing the code. Temp equals to head. Now head is 100, so 100 is put on the temp. So this pointer is pointing to this node. Now see, next you should update this head. I should check whether only one node is present. How to check? See, now the pointer part will be 0. Pointer part is 0 for which node? Last node. So now head is pointing to this node. That means this is first node also. So first node and last node are same. So see here, first node pointer is 0. That means there is only one node present here. So I am writing the condition to check whether only one node is present. See here, if head next equals to 0. Now see, now head is 100, 100 next is 0. That means no node is present after this. So only one node is present. So what to do? First thing is I should update this head pointer. That is head equals to 0. Now this is updated to 0. That means this pointer is getting cancelled. Now this node is not part of a linked list. Now I should remove this node from memory. So I am writing free temp. Now temp is 100. So this 100 node is deleted. And this temp is also deleted. Now see, now the linked list is empty. This is how you should delete the node if only one node is present. Now see, now we will see the case when there is more than one node present in the linked list. See, I am checking the condition whether head next is 0, head is 100, 100 next is 200. So this is 200. That means there are more than one node present in the linked list. So what should I do? See here. Now I should delete the end node, last node. So see here. Now if I delete this last node means this. If I delete this 400, this node means 300 will be considered as the last node. So in this 300 pointer part, this I should update it to 0. I should write here 0. That means 0 means there is no node after here. After 300 there is no node. So this change I should make. Now I should make update here to 0. So I should access this pointer. For accessing this pointer I should know the address 300. Now how can I get 300? There is no pointer pointing to 300. So I'll create a pointer called previous node. Previous pointer. And this pointer should point towards this node. But it can't directly point towards any node in the linked list. For pointing to any node, you should start previous pointer from first node and travel one by one till it reaches 300. So see here. Now at starting, previous pointer will be pointing to this node 100. Then see, then when previous pointer reaches to 300, then that 300 next in this pointer I am updating it to 0. So this link will get cancelled. Now after cancelling, this node will be a garbage value. This is not considered as part of a linked list. Now you should remove this garbage value from the memory, or else it will cause memory wastage. So how to remove? For removing this, I need to access this node. For accessing this node, I need a pointer pointing to it. So I create another pointer called temp. and temp should point towards this node. But you can't directly point to this node at starting. You should travel from first node and you should move from one by one till it reaches 400. So see here. Now I should start two pointers, temp and previous, from starting from here. So see here, temp equals to head at starting. So temp is this pointer and head is 100. So 100 is put on this pointer. So temp is pointing to first node. Now see, now I am writing the condition while temp next not equals to 0. What is this condition? See, I should move the temp pointer one node in forward direction till it reaches 400. When temp is 400, I should not move again in forward direction. So I should stop temp pointer here. So how to stop? See, in this pointer, the next pointer is in this node, the next pointer is 0. So if this pointer part is 0 means I should not move the temp. So see here, I should see in this node. In this pointer part is not 0, it is 400. So you can move temp pointer to next node. So after this you should not move. That's why this condition. See here. Now I am checking whether temp next not equals to 0. Temp is 100. 100 next is 200. It's not equals to 0. So I should create one more pointer, previous pointer. And that pointer should point towards same node. So I am writing previous equals to temp. Now I am creating another pointer called previous. And what is temp? Temp is 100. So 100 is stored here. So this pointer is pointing to node 100. Now next step is you should move the temp pointer one step forward. So I am writing this case. Temp equals to temp next. Now you should store 200 in this temp pointer. So where can you get 200? From this pointer. So temp is updated to temp next. Temp is this thing. I am updating the value to temp next. Temp is 100. 100 next is 200. So I am updating this to 200. So this pointer is getting cancelled and this temp pointer is pointing to second node. Now see. Now I should go back to the same step and I should check this condition. Whether temp next is not equals to 0. Temp is 200. 200 next is 300. It's not 0. So I should enter in this statement previous equals to temp. That means temp is 200. 200 is put on this previous pointer. So this pointer is getting cancelled and this pointer is pointing to the node which is having address 200. Now temp equals to temp next. Temp is this pointer. In this pointer I am updating the value to temp next. Temp is 200. 200 next is 300. So I am writing at 300. So this pointer is getting cancelled and this pointer is pointing to node 300. Now go back to the same condition. Check whether temp next not equals to 0. Temp is 300. 300 next is 400. It's not 0. So enter previous equals to temp. That means temp is 300. 300 is put on this previous pointer. Now this link is getting pointer is getting cancelled and this previous pointer is pointing to 300. Now temp equals to temp next. Temp is 300. 300 next is 400. So 400 is put on this temp pointer. So this pointer is getting cancelled and this pointer is pointing to 400. Now go back to the same condition and check whether temp next not equals to 0. Temp is 400. 400 next is 0. So this is contrast. Now it does not enter into this condition. It stops here. Temp points towards this 400 and again it does not move. So stop here. Now see, now what change you should make? In this pointer I should store 0 to cancel this link. So how to access this node? This 300 is stored in previous pointer. So I am writing SC. Previous next equals to 0. Now previous next is what? Previous is 300. 300 next is this thing. In this pointer I am storing 0. So this link get cancelled. And now this node is not part of a linked list. Now I should remove this node from memory or else it will cause memory wastage. How to remove? This address is stored in temp pointer. So I am writing free temp. Now temp is 400. So this 400 node is deleted and this temp pointer is also deleted. Now see, now you have a linked list with only 3 nodes. You have deleted the 4th node. This is how you should delete the node at the end of a linked list. Now see, now I'll teach you how to delete a node from a particular position in the linked list. See, now I should ask the user at what position you want to delete a node. So I am asking the user, see here, printf enter position. Now see, now if the user enters some position if he enters, that should be stored in this position variable. So how to store? By using scanf function. So I am writing scanf %d comma and position. Now this value which he enters is %d. That %d is position. It stores in the position variable. Now see, now let's see this case. There are 4 nodes in this linked list. Suppose if the user enters position is 5. That means 5th node should be deleted. But there is no 5th node in the linked list. So you can't delete. So what is the condition? See, the position which he enters is greater than number of nodes present in the linked list. Number of nodes here is 4. This position 5 is greater than 4. So you can't delete. So that I am writing the condition. See here. If position greater than count is to count the number of nodes in the linked list. So if position is greater than count, then print invalid. Now see, now so it prints invalid and it again asks the user to enter correct position. So if the user enters 3, now what it happens, let's see. 3 means I should delete the 3rd node. This is the 3rd node, 300 is the 3rd node, I should delete it. How to delete? See here. Now suppose if this node is deleted, then this in this pointer part, in this next pointer of 200, I should store the address of next node. So if this 300 node is deleted, means the next node of 200 is what? 400. So I should store 400 in this pointer. So this link will get cancelled and this pointer will point to the node which is having address 400. Now see, now to access this pointer, how I can access? If I know this address, then I can access. So 200 next I can access. So now how to get this 200? I need a pointer to point towards this 200, but there is no pointer. So I'll create a pointer called previous, and this previous will temp. Now that temp pointer will point to this node. So but directly it can't point. It should in linked list you should start from temp equals to first node. Then you should travel one by one till it reaches 200. So how to do? See, first thing is I should create a pointer temp, and that pointer should point to first node. Then one by one in each step I'll move and till temp reaches 200 I'll stop. Then see, after making this change, next step is what? See, this node is not part of this linked list, it's deleted. But see, but you have data stored in memory. So what you should do? If this should be removed from the memory, or else if you don't remove from memory, it causes memory wastage, because this is a garbage value. Now you should remove it from memory. How to remove? For removing this from memory, you need a pointer to access this node, but there is no pointer for this node. So I should create another pointer called next node, and this pointer should point this node. Then if I write free next, then this node will be deleted. Now this temp is moving at first position, then second position, it reaches here. Then after moving this temp to here, you can write next equals to temp next. You will get this next position pointing to this node. Let's see by step in this code. See here. Now else part. Now this is now I want to delete 3rd node. How to delete? See, now I am pointing, first thing is temp equals to first node. So I am writing, see, temp equals to head. Head is 100. So 100 is stored in temp and temp is pointing to first node. Now see, I am writing the condition while I less than position -1. What is this condition? See, this condition is that temp should move one step forward, but it should stop, this temp should stop at 200. It should not move further. That's why I am writing this condition, terminating condition. Now what is this I? I tells that at what node temp is pointing to. At starting temp is pointing to 1. So I'll define at starting int I equals to 1. Now see, this variable I is 1 because this temp is pointing to first node. Now see, now I'm checking this condition whether I is less than position minus 1. I is 1. Then position minus 1 is 3 minus 1, 2. So now 2. So 1 is less than 2. I is less than position minus 1. So you should create another point. You should move this temp pointer to next node. How to move? See here. Temp equals to temp next. Now temp is this pointer. In this pointer I am updating the value to temp next. Temp is 100. 100 next is 200. So this is changed to 200. So this pointer is cancelling and this pointer is pointing to this node 200. Now this temp is pointing to second node. That means I should be 2. So I should increase I value by 1. So I am writing I plus plus. Now 1 is updated to 2. Now go back to same step and check whether I is less than position minus 1. I is 2. Now position minus 1 is 3 minus 1 2. So this I 2 is not less than 2. It's equals to 2. So this condition is not satisfied. So it does not enter into the statement. That means it does not, temp pointer does not move to next node. It stops here. Now see, now next pointer I should take in this next node. Now next pointer should point to this node 300. So I should store 300 here. Where can I get 300? From this pointer. Now you can access this pointer by using temp next. So see here. Now next equals to temp next. Now what is temp next? Temp is 200. 200 next is 300. That 300 is stored in next. So this pointer is pointing to this node. Now see. Now make the changes. What change you want to make? See here. In this pointer, I should store the address of next node. So if you delete this node, the next node of 200 is 400. So 400 I should store here. So how can I do? See here. Temp next equals to next. Now see. Now let's name this node as next node, not next, because it causes confusion. Because two next are there, so it will cause you confusion. So see, next node. Now see, this is next node. Now see, temp next is what? Temp is 200. 200 next is this pointer. In this pointer I should update the value to next node next. Next node is 300. 300 next is 400. So 400 I am storing in this pointer. So this link is getting cancelled and this pointer is pointing to the node which is having address 400. Now this node is not part of a linked list. Now there is only 3 node, 1, 2, 3. But now you should free this node because it causes memory wastage. How can you free? See here. Free next node. Now next node is what? 300. So 300 node is removed from the memory. So this link automatically gets removed. So see, now you have only 3 nodes in this memory, in this linked list. This is how you should delete a node from the from particular position. That's all for today and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.